Hello everyone, my name is K1 and in this session I want to talk about using a HECRAS model and how we can use this kind of unsteady model to provide flood assessment. Unsteady model is a kind of model that can help you to see changes during the time. So because of that, we call it unsteady. It means that it depends on time. I have to mention that when you want to use a HECRAS model, you have to provide some special folders for yourself to save your DEM file and the projection file, which shows you the specific path that you can manage your files in a good way. You have to provide DEM because we want to produce our geometry by using DEM, and then projection is really important when we want to provide our model based on GIS tools in HECRAS. And when you add projection, the model can recognize the coordination of your location, and in this way you can add different layers and you can see what will happen during the flood. So we have to consider that the resolution of the file is really important. For example, you have to see if the resolution is high. In this way your computational cost would be high, but if you want to analyze some rivers with a smaller scale and dimension, you have to use some DEM with the high resolution. But for the people, for example, who wants to use DEM with the resolution of 10 meters but the width of the rivers are 5 meters, they cannot simulate flood in this small river very well because the dimension of the pixels are large and you cannot see what will happen in the river boundaries. So my suggestion is that based on your model and based on the place that you want to analyze it, you have to choose your DEM file, and in this way you can provide your geometry. The version of HECRAS is 6.6. This model is really I mean that it helps you to provide some new boundary condition, and you can see, for example, what will happen when we have a precipitation. You can add precipitation at the boundary condition. Precipitation is a kind of normal boundary condition, and we cannot ignore this because when we have a flood and if we skip precipitation, the volume of water will decrease. But in this session I will talk about the simulation of flood, 2D flood, which is unsteady, but we will work on adding precipitation as a vertical boundary condition in next session. So the first step is opening your HECRAS model, and then you can file your you can save your new project, and then choose the folder that you provided for this specific goal. For example, I provide this folder in this location and I call it training. I will save my project inside this folder, HECRAS model, and I call it my project. Then I will OK the model, ask me if I want to use any special unit for simulation, for example, because I want to use metre for my unit, so it is good. But whenever you want to change the unit, you can use option and then unit system. In this way you can change the unit for this software. The first step for simulation flood based on GIS tools is opening the raster tools. Here we choose GIS tools raster mapper, And the first step is, which is really important, is adding the projection of the DM file here. For example, I save the projection in this folder and then open it. Here, when you add your projection to your HECRAS, it gives you some information related to the DEM file that you saved and about the coordination and the location of the area. Then you will apply it, and okay, the next step is adding the creating the new Rust terrain. So you will choose this plus and then add your terrain. Then when you click on open and then create the HECRAS, try to create terrain based on your based on its work. So we have to wait, and it will add this terrain. When it is finished, we can see it will add it. I think it may take a bit time, so I try to stop the recording, and when the operation is finished I will start again. Well, when the operation become completed, you can see the terrain added perfectly, and then you can close this window, and you can choose file and save your RAS mapper. One of the other things that you can do, adding a map layers, which you can use the imagery to your model. So you can choose hybrid and then add OK. In this way you can see the area simultaneously. So now we have our RAS mapper, and we save it. Close this window, and we will go to the next step, which is providing the geometry, which is really important. When you click on it, the geometry will add it to the HECRAS, and you can see it more specifically. My DEM model has high resolution. I mean that it is it has 1 meter resolution. Based on a place that you want to model flood, you can choose your area of interest. I have to mention that in the United States we can download data related to the discharge from some stations like NOAA station or USGS station, and specifically you have to choose the location of this station because it gives you the value of discharge in this in a specific point. I just wanted to mention this point to you because you want to simulate